Okay, so in chapter 6.3, what we have already covered so far is on graph of linear function and equation of a straight line. Okay, and in our last lesson, we have also covered or I briefly mentioned about gradient as well. Okay, so we know how to draw graph, equation of a straight line. We also have covered that, which is your y equals to mx plus c, whereby m is your gradient and your c is your y-intercept. Okay, and then in the last lesson, I briefly introduced the concept of gradient to you. Okay, whereby gradient will be found by using the formula rise over run. Okay, and what I mentioned was that usually we have two different kind of diagonal lines, upward sloping or downward sloping. Okay. And in upward sloping graphs, our gradient value will have to be positive. And then for our downward sloping graph, our gradient will have to be negative. Okay? So I want us to now turn to our textbook, page 158. Let's set up the visualizer. Okay, turn to our textbook, page 158. Looking at the diagrams that are found in your textbook. Okay, it is our time to warm up. Page 158 to 159. I'm just going to do a rough sketch of the question. Okay, so in your textbook itself, you have a diagram that looks somewhat like this. Right? You all have this, right? Okay, so in this question, okay, what they want you to do is to find out what is the gradient of the line. Okay, in order for us to find the gradient of the line, we need to find out 2 points, okay, on the line itself. Right? How do I find the 2 points? You don't anyhow choose a point. Okay? And the 2 points must be such that it will help you to find out or to actually bring out a right angle triangle. Okay? So that is the purpose of us finding 2 points. Okay? The 2 points needs to be very nicely found such that if you look at the line in your textbook, I want you to look at, okay, the point 2, 6. Do you all see a point 2, 6? You all see it on your textbook? Okay? Sorry, the visualizer is not working, so I really have to make do. Okay, so you really need to follow what I'm saying from the textbook and match it to this diagram here. Okay? I want you to see that that point itself, do you see that it passes through the box? Okay, your corners, okay? It passes through very nicely. You all see that? It passes through the corners in a very, very nice manner. It is not like, okay, having a line that is going through out of nowhere. Alright? If you choose a point like this, okay, whereby it doesn't cut very nicely through the corners, it becomes very difficult for us to determine the gradient. Right? So therefore, when we look for the points, we look for points that passes through the corners in a very nice manner. That's why I want us to see that 2, 6 itself has a very nice point. You all see that? Okay? Now we need 2 points in order for us to form our right angle triangle. So another point that we can take, okay, will be maybe one that is right at the y-axis, whereby there is a number 2. So that is one possible point. Okay? Another point that you can consider, if you look at the diagram, okay, is actually maybe 1, 4. You see how they are very nice points? They pass through the corners very nicely. Okay? Don't just look at what's on the whiteboard, please look at your own diagram in your textbook. Okay? So these are all very decent points for us to choose from. It is up to you which one you want to choose, so long as you choose 2 of them. Okay? So maybe as a start, okay, we can consider choosing this point and this point. Okay, and then we form our right angle triangle in this manner. Right? Why do I need a right angle triangle? Because that is how our rise and run is being defined, whereby this is our rise and this is our run. Okay? So the rise is based on number of units. So we count that for this distance over here, it is from 2 counting all the way to 6, and that is 4 units. Okay, from 2 to 6, that is 4 units. And then for the run itself, this horizontal distance, it is measuring from 0 to 2. Okay, if you look at your own diagram, 0 to 2, and therefore the run is actually 2 units. Hence, for us to find out what is the gradient, that will be equals to rise over run 4 divided by 2. Okay, and we get the value simplified form to be 2. Okay, and this is correct because we know also that this is an upward sloping line going upwards, and for upward sloping line, the answer must be positive. You understand? Okay, so that's how we get our gradient value for this particular line. Questions? Yeah? Now let's take a look at part B. Okay, for part B itself, we have a line that actually cuts through like that. It touches the y-axis at 4, x-axis at 8. Okay, so how do I find out the gradient? Since it actually cuts at 4 and 8 already, we have a very nice right angle triangle that looks like this. Agree? Okay, so now in order okay, for this right angle triangle is actually from 0 to 4, and that is 4 units. And for the run, it is from 0 to 8. Okay, so 8 units. However, something that we must observe is that this line, is it going up or going down? Down, right? So if it's going downwards, the gradient must be negative. Therefore, we must intentionally put in the negative sign. Okay, so it's a negative, rise is 4, run is 8. And then we simplify this fraction and we get negative half. Okay? Understand now? Let's look at part C. Okay? For part C, we have a line like this. Okay? Whenever we find gradient, there are two important questions, okay, that we must always be able to answer. First one, is it upwards or downwards? Okay, so that we know is it going to be positive or negative. Right? So okay, second is what are the 2 points? Okay, what are the 2 points of forming your right angle triangle? Right? So in this particular case for part C, okay, you find out what are the 2 points. It's really up to you what you want to find. Okay? So because I don't have the grid, it is very difficult. Okay? 2 points that you can consider is maybe one that is at, let's say, 8 and 3. Okay, that is 1 point that you see that passes through your grid very nicely. Another one is maybe this one that passes through at 4. Okay, or you can even choose this one over here, okay, that passes through at -3. Okay, any points that are in between, I will find that it is difficult to read and difficult for us to form a right angle triangle. Okay. So now, to find out what is the gradient, okay, so let's say if I choose this point and this point, okay, then my right angle triangle is this one here. Okay, and my rise will be here, my run will be this. Okay, so to count the rise itself, it is from 0 all the way to 3. Okay, so our rise is 3, and for our run, it is from 4 to 8, and that is 4 units. This line is upward sloping as mentioned in the first question, so that's why it's a positive value. We don't need to write the positive sign. Okay, hence we get the answer 3/4. Now what if instead of choosing these 2 points, you decide to choose maybe this one and this one instead? Okay, the logic applies the same way. We are looking at the big right angle triangle. Our rise will be in this case. We are counting from -3 to 3. And -3 to 3 is how many units in total? How many units are there from -3 to 3? 6, right? Because from -3, we're just counting number of units. Okay, down here we'll have 3 units, down here another 3 units. So it's a total of 6 units over here. And then for the run itself, we are counting from 0 all the way to 8. So there are 8 units. Okay, so another way for us to find the gradient is that upward sloping positive 6/8, which simplifies also to 3/4. So demonstrate over here is that regardless of the points that you decide, once we simplify our fraction will be the same. You understand? Okay? Okay, then let's look at part D. For part D itself, you notice that our line doesn't pass through the y-axis at all. Okay, or neither does it pass through the x-axis. Okay, so again we have to find 2 points. Okay, so can you suggest one pair of points to me? How can you tell me one pair of points that you would choose for part D? 2 and 4. What is 2 and 4? I want a pair of coordinates that is on the line. 4, 2. Is it 4, 2? What do you say?
4, 2.
4, 2. Okay. So we find that 4, 2 is a point that's over here. X is 4, Y is 2. Agree? And then, can you give me another pair of coordinates, Isan? Eight and 3. The x-axis has no 8 at all. It's always x first then y. Sorry? 3, 8. Okay? So, Isa notice that 3, 8 is another possible one. Okay? Are there any other possibilities, Ernest, that you might have chosen? Another pair of coordinates, please. Sorry? Can't hear you. Huh? I want you to find another one. There is another one. Yes, Leon. Sorry? 14. 2, 14. Okay? So yes, there's another one. 2, 14 that we can choose. Okay? It doesn't matter which one we take. Okay? We can form right angle triangle. One that is over here like that. Another one is like this. Okay? Or else you can have the one big right angle triangle. Regardless of the case, your gradient itself, if let's say you were to take this point and this point, the rise will actually be from 2 to 8, that is 6 units, and the run will be from 3 to 4, that is 1 unit. Okay, and hence our gradient will be 6 over 1, and that is 6. Am I right? No. What's wrong?
It's a downward slope, so you have to write negative.
Okay, it's a downward one, so must write negative. Great. Okay, so do take note of that. Okay, don't just actually do rise over run. Make sure that you always determine whether it's outward or downward sloping first. Okay? Questions? Alright? Now, whenever we have our graphs, okay, given like that and we find the gradient, we may also have the opportunity to find out, okay, what is the equation of the straight line. Okay, because I don't have the visualizer today, not able to do more with the diagrams in the textbook. However, I want us to turn to our notes. Okay, so in your graph worksheet, okay, your set of graph paper, I want you to take out your notes itself. Remember this worksheet that I've given you? Okay, please turn to that. Okay? Do we all have our worksheet? Where's the worksheet? This is the graph paper. Okay, we're looking at question 3. Okay, it says that the graph below shows a straight line. We want to write down the coordinates of A. Okay, what will the coordinates of A actually be? Ready? Can I call a name? Ready? Okay, I think Joshua is the last one. Can you tell me what are the coordinates of A in your sheet? What's the coordinates of A? X plus and Y. Two and negative 2. Great, thank you. Okay? Alright, so we get 2 and negative 2, okay, for the coordinates of A. You may write down your answer either in the empty space that you have on the worksheet or at the empty space at the back. Okay? So that all your answers and your question are together. Now looking at part B, okay, we want to find out what is the gradient. Okay, would I just give you 1 minute to work out the gradient on your own before we run through the answer? Okay, the 2 points are already very clearly indicated for you, so it isn't difficult for you to know what are the 2 points and determine the gradient. Please calculate the gradient. Okay, I hope that you have really gotten the gradient. In fact, I know that some of you are just waiting for the answer. If you're waiting for the answer, I don't know how to help you anymore. Yes, Brazil? Yes, I can clearly tell that you didn't read your worksheet. Find a way to help yourself. You have a classmate beside you, behind you, share please. Okay, I've been done with this kind of nonsense telling you never bring, never do, whatever nonsense. Okay, if you're not going to level up, right, then you'll be left behind. Full stop. Okay, I've been done of pulling you all, okay, getting you all to come back to wherever we are. Okay, so the gradient itself, in this case, you would have seen that we have the points A and B. Form your right angle triangle. Okay, the rise itself, count the number of units, it is from -2 to 6, hence there are 8 units over here. And the run itself, okay, there will actually be from 2 to 6 again, that is 4 units. Okay, if you don't understand what I'm trying to say, read according to the axis, there's number 2 and number 6 on your x-axis. So there are 4 units. So the gradient will be 8 over 4, that is equals to 2. Okay? So that will be the answer. Moving on to question 4. It says that the graph below shows a straight line. Okay? So now this is a unique question whereby there are no grids given to you. Okay? When there is no grid at all, you must still know how to count. The counting principle remains the same. Okay? So they give you certain critical numbers. This is 3 and this is 5. Okay, and we can observe that there is a right angle triangle very clearly, which is this one over here. Okay, so in this right angle triangle, see that this is the rise and this is the run. Okay, but before that, in part A itself, the question says to write down the coordinates of the y-intercept. I think my mic is really not working. Okay, I tried it just now already, don't know why it died. Alright, so anyway, okay, to know what is the y-intercept, I mentioned that the y-intercept is where the graph itself passes through the y-axis, and that will be this number over here. So therefore, to find out the coordinates, it is not just number 3. Okay, coordinates must be of this form. First number is from the x, that is 0, and from the y-axis, that will be 3. So therefore, the coordinates will be 0, 3. That's the answer for part A. And then for part B itself, okay, the question asks for the gradient. So the gradient in this case, okay, what do you think would it be actually? Let me choose another one. 8. I believe Yanhoi you're beside 8. Yanhoi, can you tell me what is the gradient in this case?
Take the gradient.
What is the rise value?
The rise is 3.
And the run?
Is 5.
And the answer?
So it's 3/5.
You sure?
Because the rise gradient is usually rise over
Yes, I know that the gradient is rise over run, but I want us to check whether 3/5 is the correct answer. Is this line downward sloping or upward sloping? It should be a negative 3/5. Thank you. Okay. Alright, so the gradient will be negative 3/5 in this case. In part C, question wants you to write down the equation of the straight line. So we have already found the gradient and we know the y-intercept is 3. Okay, so in this case, what will actually be the equation of the straight line? This is what we covered in our last lesson. Okay, Binwei. Okay, yes, Marcus, can you tell me what is the equation of the straight line? Equation of the straight line. I'm reading. Y equals mx plus c. Plus 3. Like that. Is it? Okay. Thank you. Have a seat. Do you agree with this? Marcus gave y equals to negative 3/5x plus 3. Agree? Okay, so yes, the gradient is negative 3/5. And then the y-intercept, we know that the value is 3, so that's why we put a plus 3 over here. Okay? And so that will be the answer. Yeah. Yeah. Okay, okay. This kind of things you chase me. Then my homework never submit on time, okay, you should chase. Was it on time? Then. Okay, so now moving on. Okay, now we know about gradients already and we know how to find the gradients. Okay, about diagonal lines. Are we ready? Okay, another type of line that we need to deal with, okay, when it comes to straight line, other than being diagonal, they are your horizontal and vertical lines. Okay, you must know what is considered horizontal and what is considered vertical. Horizontal lines are like that, vertical lines are like that. Okay? Okay? For horizontal and vertical lines, they are very unique cases. Okay? So when it comes to the gradient and also its equation itself, it can be rather unique. For horizontal, okay, what the gradient will be, if we were to use our formula, rise over run, my first question is, is there any rise for horizontal? There is no rise, right? So our rise is actually 0, but we do have 1. Agree? Okay, so it is some number. If I take 0 divided by any number, what is the outcome? 0, right? Therefore, for horizontal lines, our gradient will always be 0. Okay, so that is the understanding that we must have. Now, what about vertical lines? Okay, for vertical lines, we see that there is actually a rise. Agree, there is a rise, right? But there is no run. So our rise itself can be some number depending on the question. But our run itself, okay, the horizontal part, there is nothing, which is 0. If I take something to divide by 0, what is the outcome? Is it 0? Can you check your calculator? You take 2 divided by 0, 3 divided by 0, what do you get?
Math error.
It's a math error. Okay? Math error doesn't mean a 0, it's just undefined. Okay? There's no definition to it, there is no number to it. Undefined doesn't mean 0. Okay? No answer doesn't mean that you leave it blank. Okay? The answer is actually that it is undefined. Alright? In mathematics, we call it undefined. Yes. Okay? So you need to know that vertical lines, gradients are undefined. Okay? Please actually, I don't know why you create a pair of rulers. Alright? If you want to play the rulers, please get out. Okay? Now, going on to your horizontal and vertical lines, we already clarified about the gradient. Next thing is about the equation of the straight line. Okay? Equation, we know that it must be y equals to mx plus c in general. Okay? For horizontal, since we know that the gradient is 0, 0 times x becomes 0, nothing, right? So that means that our equation, okay, will be y equals to whatever number that is. So for example, okay, I have this straight line over here. Maybe I'll use a purple marker. Emphasize on that straight line. So this is a horizontal line. It will pass through your y-axis at a number. Okay? So horizontal lines confirm will pass through your y-axis. It will just never pass through the x-axis. Okay? So because it passes through the y-axis, I will know what is the y-intercept value because it passes through y-axis. So whatever number it is over here, that will be our c value. Therefore, our equation must be y equals to that number itself. You understand? Okay? But now it is a different story when it comes to vertical lines. For vertical lines, our gradient is undefined. You cannot just write y equals to undefined x plus c. No such thing, okay? Because undefined is the word, x is a variable. Otherwise, it will become u times n times d times e and all that. It doesn't make sense at all. Okay? So therefore, the equation for vertical lines is defined such that if you have a pair of axes and the vertical line is in this manner, it will pass through a certain number on the x-axis. Okay, it will pass through a certain number. So instead of y equals to something, for vertical lines, the equation differs. It is x equals to that number. So vertical lines is the part whereby it's a unique case. It is x equals to whatever number that appears here. You understand? Any questions? Okay, so there are also other unique cases. If I have a set of axes, okay, over here like that, and let's say I have a vertical line that is directly on my y-axis. Okay, this is my vertical line. What do you think this equation of this line should be? What is the equation of this line? It's a vertical line, So must be x equals to something, right? What is that something? 0. a horizontal, so must be y equals to something, and that something will be 0. Okay? I want to give you homework, but then visualizer is not working. I can't run through this with you. Okay, so I tell you what, right? Since now the time is actually about 1:40 soon already. Okay, tomorrow I'll give you your homework because the homework is I want to give it to you in worksheet form, right? I'll make sure you bring your graph paper tomorrow, okay? Because I want to run through one of the questions with you, right? Then after that, tomorrow I will finish up chapter 6.4. Okay, home-based learning on Thursday, we will do chapter 8. Understand?
Hey, oh. I forgot to bring the Z book.
Here's the angel for today.
Ôi, Jovan, I want a bottom cap. Bottom cap.
Anything else? Any more?
Wow.
Okay, pass this test.